Boys and girls, now I am to calculate electric bill. The equation of electric bill W will equal to VIT or V square by RT or I square RT. And if I use P equal to W by T, then I can say that W will equal to here P into T. This is a key or main equation of electric bill. Now I need to use this equation. Before using this equation, we need to know two things. The first one is here, boys and girls. The first one is we want to convert the time in terms of hour. So no need to convert time into second to calculate electric bill. In this step, time must be in hour format. In second step, electrical power P must be in terms of kilowatt. Must be in terms of what? Kilowatt. So by maintaining these two things, if you maintain kilowatt and hour, you can say that kilowatt hour. And this kilowatt hour is in short known as BOT. BOT means what? BOT means here Board of Trade Unit. I can say that here 1 kilowatt hour will equal to 1 BOT, Board of Trade Unit. So electrical board uses this unit as a kind of electric unit, in short unit. So 1 unit electricity will equal to 1 kilowatt hour electricity, or in short this is known as 1 unit. Okay, then by giving an example, I am to calculate electric bill. Say this is a resistance. This very simple circuit. This is a resistance. The value of this resistance is R ohm. And here this is a battery or electrical cell is connected with the resistance R, and this is a wire, and this is a key. So this battery or electromotive force and this key or switch. If I connect this switch here, then electricity flows in this direction. Here I amount of current will flow. So I want to calculate electric bill here. Say electric work done W will equal to, I can use the first formula VIT, the second one V square by R into T, the third one I square R into T, or the fourth one P into T. If I use here VIT, I can say V into I then T. Boys and girls, here V is replaced by electromotive force E. So if V will equal to electromotive force E, then here E into I into T. You know, boys and girls, this E into I or this V into I will equal to electric power. Will equal to what? Electric power. You see here, V into I will equal to electric power. And you know, electric power, the unit of electric power is kilowatt. Simply watt. SI unit is watt. Okay. But before calculating electric bill, you need to convert this power P in terms of kilowatt. So to convert this into kilowatt, E into I is divided by 1000, because you know that 1000 watt will equal to 1 kilowatt. So E into I is divided by 1000. And here time T is the total time. If you want to calculate the electric bill for 1 month, then you need to convert this total time in terms of hour format. So total hour it runs this electrical device, then this is the total time T in terms of hour format. So this is, let this whole term is A. So A unit electricity will lost or experienced by this electric device after maybe 1 month or maybe after 1 day time. And the total bill will equal to total unit into the cost per unit electricity, say this 8 taka, so this multiplied by 8 taka. So this is the total cost of electric bill. Boys and girls, this is the total cost of electric bill. Okay, so electric bill will equal to total unit of electricity that is lost by this electrical device and multiplied by taka per unit electricity, multiplied by taka per unit electricity. Okay, so this is the total bill. Now boys and girls, I want to find out electric bill by the following circuit, by giving an example. Say this is resistance R1 and this is resistance R2. Here a battery is connected with a key or switch. R1 resistance, the value of R1 is say 2 ohm, and now the value of R2 is here, R2 will equal to 3 ohm. Now the total electromotive force E will equal to, let this is 10 volt and switch is open, key is open. So when key is open, then inside the circuit here I amount of current will flow. Now boys and girls, I want to calculate electric bill. If this circuit turn on 5 hours per day for 1 month, and cost per unit electricity is 2 taka. Then calculate electric bill. The first one, here my given information, total electromotive force E equal to 10 volt. The first resistance R1 equal to 2 ohm and the second resistance R2 equal to 3 ohm. So we want to find out total equivalent resistance of this circuit. Here R1 and R2 are connected in series connection. So total resistance R will equal to R1 plus R2. See here R1 equal to 2 ohm, R2 equal to 3 ohm. So R1 plus R2 will equal to here 5 ohm. Now electromotive force is given and resistance is given. By using this electromotive force and resistance, the formula of electrical work done W will equal to, is it VIT? No, I is not given here. Is it V squared by R into T? Yes. Is it V squared by R into T? Why? Because V is given here and the resistance R is also given here. So W will equal to V square divided by R into time T. Here V will equal to the given electromotive force, that is 10 volt. So 10 square divided by R, total R will equal to 5 into time. This circuit is turned on 5 hours per day for 1 month. So for 1 day 5 hours, but if you consider the whole amount of time in 1 month, this multiplied by 30 is multiplied by 30. Now boys and girls, here 5 and 5 will cancel out. So 30 into 100 will equal to 3000 watt hour. Boys and girls, you need to convert this watt hour into kilowatt hour. So how can I convert this watt hour into kilowatt hour? Dividing this whole equation by 1000. So by 1000 and multiplied by 3000 watt hour is converted into kilowatt hour. So this 3 kilowatt hour. Now 1 kilowatt hour will equal to 1 unit. So 3 kilowatt hour will equal to 3 unit electricity will lost or experienced by this electrical device. Here cost per 1 unit electricity is 2 taka. So the total bill will be 3 unit electricity is lost by this circuit. So 3 into cost per unit electricity, that is 2 taka. So the total cost is here 6 taka. So the total cost is here 6 taka. So total bill of this circuit after 1 month is 6 taka. Now boys and girls, your homework. At first draw an electric circuit. Boys and girls, draw an electric circuit, any kind of circuit you can draw. At first draw an electric circuit and then find out electric bill of that circuit. Then find out electric bill of the circuit. Boys and girls, now I am to give summary of my lecture 3. You see boys and girls, after this lecture you can explain the following topic. Number 1, you can say what is called electric work done. What is called electric work done. Number 2, the equation of electric work done. Number 3, calculation of electric work done or electric bill. Electric work done or electric bill. Number 4, calculation of electric power. So this 4th thing is the very important topic of this chapter. Boys and girls, thank you for watching this lecture. Thank you very much.